introduce the concept of relationship. Let me introduce the relationship between the return period and the probability, because what I am given by the law is the return period. The laws tell me that the bridge should be designed for a return period of 200 years. The laws tell me that the design variable for the bridge, the design variable peak flow to design the bridge, should be estimated for a return period of 200 years. So basically what I know is TU equal to 200 years. Okay, so the question now is, what is, for this method of annual maxima, the probability corresponding to a return period of 200 years? And there is a relationship that can be used with the purpose, very simple, which says that the probability of not exceedance of a random variable x is equivalent to tx minus 1 divided tx. And this relationship applies only for the annual maxima method. So what you have to basically learn here is the relationship, and you have to learn without any doubt that it applies only for the annual maxima method. It applies only if you have one observation each year. And let me make an example. To make the example, let me refer to a return period of 100 years, not 200, because it's much easier. So what is the probability of not exceedance, which corresponds to a return period of 100 years? And keep in mind, a return period of 100 years means that a flood of the given magnitude, a flood of magnitude x, occurs on average once every 100 years. So what is the probability of not exceedance? Then the probability of x would be equal to 99 divided by 100, which means 0.99. What does it mean? It means that there is a huge probability that x is not exceeded, which is fine, because x occurs on average every 100 years. So it means that if you draw by chance from a sample of 100 annual peak flows, if you draw a number by chance, you have like a pot with 100 numbers, and these numbers are annual maximum peak flow, and you put one number by chance, this relationship tells you that 99 times over 100, you get a number that is lower than x, which is fine, because you have only one, in 100 years, you have only one occurrence on average of x. So you understand this relationship works. But keep in mind, only if you have the annual maxima method, because let's suppose that you get every year two numbers, two peak flows, then you understand that the return period would need to be computed with another relationship. This applies only if you have one peak per year. Okay, but this is very useful, because now I can put this, I can substitute in this relationship of the Gamble distribution the relationship between the probability and the return period, which is better for me because I'm not given usually by laws the probability, the design probability, I'm given the design return period. But before then substituting, let me observe that here I need to derive x, so I need to derive an explicit relationship for x. So I need to invert this. Is it clear? Because this relationship is giving to me the probability as a function of x. Instead, I need to invert it to get a relationship to deliver x as a function of probability. Okay, let me invert it. It's very easy. In order to invert this relationship, I need to get two logarithms. First one, logarithm with base of px. So on the left-hand side, I take the logarithm of the probability. On the right-hand side, I get minus e to the power of minus x minus me over beta. And let me change the sign, please. Minus plus.
Excuse me. The minus in the power is not in the formula of the credit.
Because I think this relationship here, it's a bit different. I need to find, because this is 1 minus e to, yeah, I know that. But, you know, this is a bit different. This is what I need to explain to you. It's written in a different way. So I'm pretty sure that I'm getting to target by using this way of writing, but then I need to explain to you what is the relationship between the two ways of writing. I think they are equivalent. At the end of the story, because I didn't notice that, at the end of the story, I think they are equivalent. Okay, but let me please continue in this way, because I'm sure that in this way I'm getting to target. And then I will need to explain to you the relationship between my writing and this writing, okay? Because I don't think this is incorrect. This is correct. It's Wikipedia, I trust it's correct. But probably it's just simply written in a different way, okay? And in order to check it, what I would like to propose you to make is to write on an Excel sheet to make the two computations separately and check if we get to the same results, okay? Because by doing it by numbers, by computing, I think it's easier to understand. But let me please move forward without looking at that for now, okay? And so I took a first logarithm, and let me take the second one. And I need, I'm sorry to delete here. So the second logarithm becomes logarithm of minus logarithm of px is equal to minus x minus me over beta. And again, please let me change the sign. Okay, we are almost there, and let me now write explicitly the expression for x. I am now getting x from the right-hand side, so basically what I get is x equal to beta minus beta, that is, which multiplies logarithm of minus logarithm of px plus me. This should be the relationship I'm looking for. And now what I can do is to substitute for the probability there's a relationship here. So basically what I would get is x equal to minus beta, which multiplies logarithm of minus logarithm of tx minus 1 divided by tx, and that's it.
What about that plus me?
There is yeah. Sorry, last thing. What you may want to make to get an easier way of writing, you could invert in the argument of the second logarithm the numerator with the denominator and change the sign. So basically, if you prefer, because if you want prefer to avoid the minus signs, you could put here. I make the correction. I don't have space to rewrite, or let me rewrite here. You may write it in this way. X is equal to minus beta times logarithm of tx divided by tx minus 1 plus me. This is a bit more, probably looks more comfortable, let's say.
There is no minus. No minus, yes.
Here?
No problem.
Oh, it's okay? Okay, perfect. And so basically, let me make a summary before I make the break. Let's keep this relationship here, and let's write back the relationships for estimating beta and me. Remember that you have n observations of annual maxima, Okay, and then we said that beta is equal to sigma divided by 1.283, and we said that me is equal to m minus 0.45 sigma. So basically, if you now look at the summary of what I proposed to you, the summary is extremely simple. The discourse has been quite long, but the summary is extremely simple. You have data, which is your information. You extract capital N annual maxima. You compute the average and the standard deviation of the annual maxima, and very easily you compute beta and me. Once that beta and me are known, you get immediately, through this relationship, the estimate of the peak river flow for the return period t. The only question that is still open is the Gamble distribution providing a reliable estimate? We need to reply next hour. And there is a second question open to reconcile my writing with the Wikipedia writing, okay? Let's take a break. And sorry for the mismatch between the writings. I didn't notice it, and sorry for the confusion.